Good morning, everyone. Sorry again that I can't be here today. I do promise that I will be back tomorrow, though. Today we're going to be reviewing first factoring the following, so hopefully everyone's given these questions a try. So let's quickly take them up as review from yesterday. So we're looking at our factoring A here, where we have x squared minus 2x minus 8. Remember that we always look to see if there's a number in front of the x squared. In this case, there's not, so remember we can say that there's just a 1 in front of that x squared. So when we do that, we can do it by inspection. So let's come up with our two numbers. So our multiplied number is the last number here, which is the negative 8. And our add number is the one that's in the middle, which is negative 2. So we need two numbers that multiply to negative 8, but add to a negative 2. So again, if you can't come up with those right away, go through the different options. 1 times 8, 2 times 4, and that's all the options that we have. So if we look at it, 2 times 4 gives us an 8, and we need to add to a negative 2. Because our multiplying numbers are negative, we know at least one of these two numbers need to be negative. We need it to add to a negative 2, so that means that the bigger number has to be negative. So we're going to have a 2 and a negative 4. Now because there's a 1 in front of that x squared, we can drop them right into our brackets right away. Remember that x comes first, so we're going to have x plus 2, and then for our second number, a second bracket, x always comes first, and this time we're going to have x minus 4 in our second bracket. Taking a look at part B here, the second one, this one does have a number in front of the x squared, so this is where we have to use decomposition. So when we're coming up with our multiply value, remember it has to be that first number multiplied by our last number. So we're going to do 10 multiplied by 12. And sorry, that needs to be a negative 12 because there's a negative in front of that 12, and that sign always has to carry with the number behind it, which gives us a negative 120. And our add number comes from the middle, which is in this case a 7. So we need two numbers that multiply to a negative 120 and add to a 7. Again, because our multiply number is a negative, we know that at least one of our two numbers must be a negative. So if we go through all our different options, you'll find that 15 and 8 are going to work. Because we need it to add up to a positive 7, our smaller number is going to be the one that gets the negative. Now, because this has the number in front of that x squared, this is where we have to do those extra decomposition steps. So we start off with redoing our equation, but this time our middle number of plus 7x, remember, gets split up into our two numbers that we came up with here. So we have a plus 15x and a minus 8x from our two numbers, and then the last number and the first number stay the same, our 10x squared and our negative 12. Remember, at this point in time, we split our equation in half, and we do common factoring in each of those two halves. So looking at our first half here, we pull out a common factor. So hopefully you see that we can pull out a 5 from both of those numbers and an x from both of those numbers. So we divide them out. 10x squared divided by 5x leaves us with a 2x. And 15x divided by 5x leaves us with a positive 3. Then looking at our second half here, we look and we can see that we can take out a 4 out of both of these, and we're going to take out a negative 4 because remember, in this bracket it's all positives here, and we want our second bracket to be exactly the same. So we're going to take out a negative 4. So when we divide that out, negative 8x divided by negative 4 leaves us with a positive 2x, and negative 12 divided by a negative 4 leaves us with a positive 3. And again, I just mentioned this, we want these two brackets to be exactly the same, which in this case they are. So we factor that out front, 2x plus 3. And then anything that's left over in front of those brackets, this 5x, and this minus 4 make up our second bracket. So our second bracket is 5x minus 4. Now that we have our two brackets, we're done that question. Let's take a quick look at C here. Again, there's a number in front of that x squared, so we know that our m value has to be 2 times the last value, which is 2 times the negative 8. So we know our multiply value is a negative 16. And our add value is always the middle, which in this case is a 6. So we need two numbers that multiply to a negative 16 that add to a 6. Once you go through the different options, we know that 2 and 8 are going to work. But again, the multiplied number is a negative number. So one of these two numbers need to be negative. And we see that our add value is positive, so that means our smaller number is going to get the negative. And again, because there's that 2 in front of that x squared, we need to do the decomposition part. So we need to rewrite our equation with that middle number split up. So we have our 2x squared, but now we're going to add in our minus 2x and our plus 8x instead of that plus 6x, and then carry down our negative 8 that's at the end. We're going to break it in half. See what you can common factor out of the front here. So hopefully you see that you can pull out a 2x. When we factor those out, 2x squared divided by 2x leaves us with just an x, and negative 2x divided by 2x leaves us with just a minus 1. Looking at our second one here, the only thing we can factor out is a positive 8. When we divide these both by 8, we get an x minus 1. Again, our two brackets equal exactly the same thing, which is what we want. So we have x minus 1 that gets carried out front. And anything that's left over is our second bracket. So we have that 2x and the positive 8. So we have our final answer here in our two brackets. Hopefully that was a nice quick review of yesterday for you and a review of the types of factoring that we saw yesterday. Today we're going to be doing some more factoring, and we're going to be looking at a few of the special cases of factoring today. So we're doing more factoring, and we're going to be looking at some of the special factoring strategies. So we're going to be talking about 3 different types of factoring. We're going to be looking at the two-step factoring, and we're going to look at difference of squares and perfect square trinomials. So the first one that we're going to be looking at is two-step factoring. This is when you take out a common factor before you factor. So we mentioned this a little bit yesterday, when we looked at common factoring, and I said when we do any type of factoring, we should always common factor first. We're going to look at examples where we need to do that today, and that's called the two-step factoring, where we common factor out something first and then continue on with our trinomial factoring. Again, if you need more time to write this down, just make sure that you ask the teacher to pause the video. So we are going to look at some examples here of this two-step factoring. So if we look at our numbers here, what we want to look at is there any number that we can divide out of each of these 3 numbers? So take a look. Is there any number that you can come up with that you can factor out of each of these 3 numbers? Hopefully when you're looking at this, you see that a value of 3 can be factored out of each of these 3 numbers. So let's common factor out that value of 3. So that 3 sits out front our brackets, and then we divide each of these by 3. So 6x squared divided by 3 leaves us with a 2x squared. This 21x divided by 3 leaves us with a plus 7x. And negative 12 divided by 3 leaves us with a minus 4. Now that we've common factored that 3 out, when we look at this trinomial here inside the brackets, to continue to factor that, we're looking at much smaller numbers, which is going to make it easier for us to factor out. and to come up with those two numbers when we're looking at the numbers. So just like we did before, we're going to pull out our multiply value and our add value, but this time we're only looking at what is now inside the brackets. Because we've already factored out this 3, that's always the first step. That's the first step of this two-step factoring. Now we're trying to get what's inside this bracket into our two separate brackets that we usually have in our answer. So our multiply value is going to come from the start, so the number that's in front of that x squared, which is a 2. And again, we're still going to multiply it by our last number, which is the negative 4. So our multiply value is a negative 8. And our add value, again, still comes from this middle number, but it's the middle number in that new piece that we just factored out. So in this case, our add value is a 7. So we need two numbers that multiply to a negative 8, but add to a 7. So again, we see that our multiplied number is a negative, so we know that at least one of our two numbers has to be a negative value. Hopefully that you see that when you do 1 and 8, 1 times 8 gives us 8, and that will add to 7 when we make the 1 a negative. So we know our two numbers are going to be negative 1 and 8. Now looking at this bracket here, because there's a number in front of that x squared inside that bracket, we know that this is where we have to do that decomposition. So that 3 still stays out front. It has to stay there. It doesn't disappear. But now we're going to rewrite it just like we did before, 2x squared. But instead of that plus 7 in the middle, we're going to put in our two numbers. So we're going to have a negative 1x and a plus 8x. And then we're still going to have that minus 4 there at the end. So again, that 3 still carries out front, but this is where we're going to break up this equation in half and look at our common factoring. So look at what can we common factor out of these two numbers here. And hopefully you see that that's an x that we can factor out of those two numbers. I'm just going to use square brackets here to break up our brackets because now we've common factoring that x out, but we still have to have brackets for when we divide it out of the rest of these terms. So when we do 2x squared and we divide out an x, we're just left with 2x. And when we have a negative 1x and divide out an x, we're just left with a minus 1. Then look at the second half here. See what we can common factor out. Hopefully you see that we can factor out a 4, and it's a positive 4, so we need to write plus 4. So then 8x divided by 4 gives us a 2x, and minus 4 divided by 4 gives us our negative 1. Now remember, this is exactly the same steps as we did before. The only difference is that we have this 3 that we're still carrying out front. So again, that 3 still stays there. But then here, when we look at our brackets, remember that our 2x minus 1, those are our two same brackets, so that bracket carries out front. So we write that one out front, 2x minus 1. And then anything that's left over, so our x from this one and our plus 4 from this one, gives us our two finalized brackets. Now, so our final answer is going to look like 2x minus 1 and x plus 4. And this is our final answer here. So the only difference is now we have our two brackets just like before, but now we have that common factored value that's out front. If you have any questions, please feel free to ask the teacher. And if he's not able to answer them, then remember you can always ask me tomorrow, or you can ask the assistance of other math teachers in the school. Let's take a look at our second example here. Again, take a look at our numbers and let's see what can we common factor out of every single one of these. And this is a step that we're going to start doing with every single trinomial that we factor. We're going to look at what can we factor out of every single one of these terms if we can factor something out. So looking through these, hopefully you see that we can factor a 5 out of every single one of these terms. So let's look at what's left after we factor out that 5. So 15x squared divided by 5 leaves us with a 3x squared. Then a plus 5x divided by 5 leaves us with just a plus 1x. And remember, we can just write that as a plus x. And negative 10 divided by 5 leaves us with a negative 2. Then we need to come up with our multiply value and our add value. So we have 3 times a negative 2 for our multiply value. So we know that our multiply value is a negative 6. And our add value is the middle term, which in this case is just a 1. So we need two numbers that multiply to a negative 6, but add to a 1. So hopefully you are getting better at being able to pick out these numbers quicker. So 1 times, 6 gives us 6. And we need to add to a 1. One of them has to be negative to make it a negative 6. Oh, and that's not going to work. 1 and 6 doesn't work. Sorry, that was my mistake. So what we need, let's see, multiply to 6 and add to 1. 2 and 3 are actually the numbers that we need to use. So please make sure you make that correction if you've already written that down. It's actually a 2 and a 3 that we need to use. So 2 and a 3, make that a negative 6. One of them has to be negative, but we want to add to a positive 1. So the smaller number has to be negative. So we need a negative 2 multiplied by a negative or by a positive 3 gives us a negative 6. And we add those up. Negative 2 plus 3 gives us a 1. There we go. Now that we come up with our two numbers, remember that 5 needs to stay out front. We can rewrite our equation here inside the brackets, but we're splitting up that middle number. So we have 3x squared. And now we're going to put in our two numbers. So I'm going to do plus a 3x and minus a 2x. And then throwing in our last number of a minus 2. Now, you may have noticed this yesterday, and I'm going to point it out today, that I wrote these in the order of the 3 and then the 2, even though when I wrote them over here I had negative 2 first and the 3. It doesn't matter which order you put them in when you're splitting up that middle number, you should still get the correct answer. So again, looking at our next step here, this is where we split it in half and common factor each of those halves. So looking at here, we have a 3x squared and a 3x. So we're able to pull out a 3x. Dividing that out, 3x squared divided by 3x leaves us with a 1x, so we can just write that as x. And 3x divided by 3x leaves us with just a 1, so we have x plus 1. Looking at our two terms here, we have a negative in both of them, so let's for sure factor out a negative. And we can factor a 2 out of both of those, so let's factor out a negative 2. And then what's left, when we factor a negative 2 there, we're just left with an x. Factor a negative 2 out of a negative 2, we're just left with a positive 1. So again, that 5 stays out front. We carry that 1, that x plus 1, whatever is in those two brackets. We carry that out front. And then our second bracket is, again, what's left in front of those brackets. We have the 3x and the minus 2. And we have our final answer. Let's take a look at one more of these examples. I want you to pause the video for a few minutes. I want you to give this example a try yourselves before you take up the solutions and continue with the video. So hopefully everyone was able to give this a good try. Let's quickly take up the solution. So looking here, I see that there's a negative in every single one of these numbers. So I'm going to factor out a negative value to make those all positives because positives are always nicer to work with than negatives. So I'm for sure going to factor out at least a -1 out of everything. But let's take a look and see if there's anything else you can factor out. Hopefully you were able to see that you could also factor out a 2 out of everything. So when we factor a 2 out of everything, and it's a -2, so this is going to become a positive 6x squared plus a 19x, and then plus a 10. Now again, this makes it much easier to work with when we're factoring something like this than when we had everything as negative and with those bigger numbers. So again, that -2 stays out front. We need our two numbers. So we're going to multiply to a 60. And again, that's from the 6 times by the 10. And we need to add to a 19. Oops. Add to a 19. So the two numbers that we're going to use are 15 and 4. 15 times 4 gives us 60. And we add those up, we get a 19. So rewrite our equation, 6x squared plus 15x plus 4x and plus our 10. Break up that equation to common factor stuff out. So what we can common factor out of a 6x squared and a 15x is a 3x, which leaves us with a 2x plus 5. Out of our second half here, we can factor out a positive 2, which leaves us with 2x plus 5. And then again, we just group our brackets together. So we have that 2x plus 5 that now is pulled out of each of those. And our second bracket is what's left over, that 3x plus 2. And there we have our final answer, common factors out front, and then we have our two brackets. Hopefully most of you were able to get to that correct answer when you tried it yourself. The next type of factoring that we're going to look at is one of our special cases, and it's the difference of squares special case. So this is when you have a binomial that's in the form of something like ax squared minus bx squared, and it can be factored by a difference of squares. Now what that means is it means that when we have ax squared minus bx squared, it means that both a and b are square rootable. So it means that they can square root nicely. They square root to a nice number. So both a and b square root to a nice number, and there's a negative between them, or a minus between them. So that's really what we're looking for. If we see that our first number square roots to a nice number, meaning that it's a whole number, and our second number square roots to a nice number, and there's that minus between them, we know that we can use this case of difference of squares. So let's take a look at our first example here. We have x squared minus 16. So if we square root x squared, so if we square root x squared, what do we get? Hopefully you remember that the square root and square are opposite, so they actually cancel each other out. So when we square root an x squared, what we're just left with is just an x. Again, we're going to look at the square root of the second piece as well. so which is the 16. Now be careful, we do take the number, which is the 16. And this is the only case that we do this where we don't carry that negative with that number because we can't square root a negative number. Because if you try and square root a negative number in your calculator, you're going to get an error. So this is the only point in time where we take a number and we don't take that negative sign in front of it with it. So when we square root 16, we get 4. So we see that both of our numbers, our x squared and our 16, so both of our terms here, they both square root to nice values, an x and a 4, and we have that negative sign in the middle. So it meets all of our conditions, so we know that we can use difference of squares here. So when we use difference of squares, what we do is whatever our square root of our first term is, that becomes the beginning of both of our brackets. So because the square root of x squared is x, that becomes the first term in both of our brackets. Then, whatever the square root of the second term, which was the square root of 16, which is 4, whatever that value is, that becomes the second term in both of our brackets. Now, the only thing that we need is in each of our brackets, we have to put a plus in one and a minus in the other. So that our final answer is x plus 4 and x minus 4. And that gives us a difference of squares case. Let's take a look at our next example here. We have 4x squared minus a 25y squared. So again, we're just going to check to see if both of those terms are square rootable nicely. So we're going to square root 4x squared. So the square root of a 4x squared, can someone tell me what that value is? Hopefully someone said 2x. Then we're also going to square root our second term. Again, this is the only point in time where we don't take that sign. We're just going to square root, and we're taking everything in that second term, not just the number. We're square rooting 25y squared. And what would that value be then? Hopefully one of you said 5y. The square root of 25 is 5, and the square root of y squared leaves us with just a 5y. So now that we see that both of those terms square root to a nice number, and that we have that minus sign in the middle, we know that we can use difference of squares. So that means that, remember, our first term in both of our brackets is whatever the square root of the first term of our polynomial was, which was 2x. So we know that at the beginning of each of our brackets, we're going to have a 2x. Then the square root of the second term, which is our 25y squared. When we square rooted that, we got 5y. So that's our second term in both of our brackets. And then remember, the only thing that we add in yet is that we throw in a plus in one of our brackets and a minus in our other bracket. So whenever you realize that the case is a difference of squared case, you should know that your brackets are going to be exactly the same, except for that one gets a plus and one gets a minus. Otherwise, your brackets are going to be exactly the same. Let's take a look at our last example here. So again, we're going to try and see if we can square root our first term. So 21x to the power of 4. And when we square root that value, what should we be getting? Hopefully you are able to say 11x, and that should be 11x squared, because the square root of x to the power of 4 is an x squared. Then our second term, square root of 256. That value, hopefully one of you said 16. And then we throw it into our bracket, so the square root of the first term. So we have 11x squared at the beginning of both of our brackets. And then the square root of our second term is 16, so that's the second half of our brackets. And one gets a plus, and the other gets a minus. Now, in this case, because we still have something that has an x squared in it, we want to see if we can factor anything further. So let's take a look at this term right here. And we're going to take a look at the first term here. Because we have this x squared, we're going to look at, can we do another factoring on this? We have two terms, so maybe we can do a difference of squares. But note that we have a plus in the middle. Because we have a plus in the middle, we can't use difference of squares. So we know that that's not going to work. And we don't have any other tricks to help us do a factoring like this that doesn't have that minus with the two terms. So we can't factor that one any further. So we know that this side's okay. So we know that we can leave this bracket here. We can't factor any further. Let's take a look at this bracket here. We see that we do have a minus in the middle. So that's one thing that we need to use difference of squares. We can square root x squared, but when we square root 11, do we get a nice number? Hopefully you're saying no or shaking your heads. No, we can't square root 11 and get a nice number. We can square root 16 and get a nice number, but not 11. So since we can't square root 11 to get a nice number, we can't use difference of squares. So there is no further that we can go with this one. I just wanted to show you that checking step, because there are some cases where something that you factor in one of these brackets can be factored that one step further. So you need to be aware of that and make sure you look for that in your final answers before you finish off, because you might actually need to do one more step in those ones. Our last case that we're going to look at is called perfect square trinomials. Perfect square trinomials have this special form. And it looks like this. We have p plus q, and it's all squared. And that's equal to p squared plus 2pq plus plus q squared. So this might seem a little confusing with all these p's and q's here, but we're going to go through this example here, and hopefully that helps clear it up a little bit. So we see 9x squared plus 24x plus 16. So what we want to do is we want to pull out the p-value and the q-value. So let's look at our definition here with this formula. So we're looking here. Our straight p-value here is p squared. That's sitting here out front. So to get our p-value, what we need to do is we need to take our first number, which is 9, and it's a 9x squared. So we need to square root that 9x squared. And when we square root 9x squared, we get 3x. So we know our p-value is a 3x. Then we need to pull out our q value. So note, looking at our formula here, we see that our q value is q squared, and it's our last term at the end of our trinomial. So our last number here at the end is 16. So we're going to square root that. So we're going to square root 16, and that gives us 4. And now that we have our p-value and our q-value, we need to make sure that it actually gives us this 2 times our pq to make sure it is for sure a perfect square. So it's kind of like the checking, just like we did with the difference of squares, where we check to make sure it met all the conditions. This one too, we have to make sure it checks all the conditions of the perfect square before we can continue to factor using that special method. So we need to find 2pq. So we need 2 times by our p-value, which is 3x, and times by our q value, which is 4. So 2 times 3x gives us 6x, and 6x multiplied by 4 gives us 24x. So 24x is in fact what our middle number is here. So we know that this is a perfect square case because it meets all our conditions. That we start off with our p squared, then we have our 2pq, which we saw was just 24x, and q squared, which is 16. So because it meets all our conditions, we can use this perfect square case. And all we do with this one is follow our formula here again. So we start off with p at the beginning, so that gives us our 3x. And that again is going to be in both of our brackets. And then our q, which is the second part. So then we do, it's exactly the same, plus 4 in this one and plus 4 in this one. And remember, two brackets that are exactly the same multiplied by each other is the same as the 3x plus 4 all squared. Remember that writing this and this are the same. We saw this when we were asked to FOIL. When we were asked to expand out brackets. We would often see something like this, 3x plus 4 squared, and we would write it like this with the two brackets. So it's exactly the same. So our final answer here is 3x plus 4 all squared. So the case with the perfect square trinomials, when you can prove using these conditions here that it is the perfect square case, you know that both of your brackets are going to be exactly the same, and it's similar to the difference of squares where the first term is the square root of the first term, and the second term in the factor is the square root of the last term in your trinomial. So we're going to look at a few more examples practicing this perfect square trinomial. So here's the next example. We have 16x squared plus 56x plus 49. So again, we have to check to make sure it meets that perfect square trinomial. We don't know for sure if it will until we check things out. So we check with our p-value. So we're square rooting the first term. So we're square rooting x squared. That's 16x squared. And we get 4x from that. We're going to also square root our q value, which remember is the last value in our trinomial. So we're going to square root 49. And again, when we're square rooting these, just like with the difference of squares, they have to square root to a nice number. As soon as we do a square root and we get something that has decimals in it, we know that it's not going to be one of these special cases. So square root of 49 gives us a 7. Check our middle number, which is 2 times p times q. So 2 times 4x times by 7. So we have 2 times 4x, which gives us 8x, and 8x times 7 gives us 56x, which again, we see that this 2pq does in fact equal our middle term, which is what we want for it to be the special perfect square trinomial. So we know that we can use that formula. So in our brackets, our first term is our 4x, and our second term is whatever our q value is, which is a positive 7. And again, because our brackets are exactly the same, we're going to throw a square on that bracket. So we have our final answer here, 4x plus 7 all squared. We're going to take a look at one more of these types of examples. Again, we're going to check out to see if it is in fact meets the conditions of a perfect square. So square root our first number, square root 4x squared. And we get 2x. Take a look at our last term, which is the q. We're going to square root the 25, which is our last term, which gives us 5. And we check to see if it meets that condition of 2 times p times q. Doing 2 times 2x all times 5. So 2 times 2x gives us 4x. 4x times by 5 gives us 20. Sorry, that should be 20x. So we have a 20x here, and we see that it has this 20x here. So it equals the right value. The only thing that we have to be careful of is it has this negative in front of this 20x, but we don't have a negative here because we didn't square root any negative numbers. So we need to be careful with that. With this negative in front, that changes one thing about our final answer. So we've got to look at what that sign is in front of that middle term in this case. So it does still meet our conditions because the value is still the same at 20x. But now when we're writing our final answer inside that bracket, our first term is still 2x, and our last term is still 5, and we can still square it. The only thing that's going to be different is because there's a negative in front of that middle term, it means that the sign in between our two numbers has to be a negative in our final answer. So we have to have this negative here inside those brackets because there's a negative in front of that middle value. So this is still our final answer here, 2x minus 5 all squared. So just remember to look at the sign in front of that middle value when you're doing perfect squares, because that negative has to carry down into our final answer here. So that's it for our lesson today. Some of the follow-up questions, if you don't get them done in class, remember they're always homework. So you're going to look at page 105, numbers 2, 3, and 9, and just do every other letter. I don't expect that you do all of the letters for each of those questions. For every single one of them, just look at every other letter. Also, you should be handed out assignment number 5 that is on factoring. It is going to be due on Thursday. And we're also going to have a quiz on factoring on Thursday as well. I promise I will be back in class tomorrow, so you will have a chance to ask any questions that you have before the quiz on Thursday.